Okay, today's notes are going to be on waves. I want you to do your notes on a right side so we can turn them into Cornell notes. So our topic is waves, and our essential question, the EQ for today, is what are the types and parts of a wave? What are the types and parts of a wave? Due to today's date. So let's first define what a wave is. Write neatly. Is any disturbance that carries energy. Okay, another vocabulary word you're going to need to use, because we're going to refer to it when we talk about waves, is the word medium. So let's kind of do like a little indent. It's not a wave, but we're going to talk about how some waves require a medium and some waves don't require a medium. So it's not like small, medium, large. We're going to talk about a medium as in, let's define it as a substance. It can be any substance in which waves can travel. And it can be a solid, any liquid, and any gas. So we tell you later on we're going to talk about, can a wave go through a solid? Can a wave go through a liquid? Can a wave go through gas? So let's just think of some examples. A solid, an example would be clear glass. Any solid, but wood, TV, a remote control, a pen. But a solid is also, for example, a solid could be glass, a window. Could also be wood. Any piece of solid. A liquid, I always think of a swimming pool, but water. A gas, example of gas is going to be air. Okay, so back up to our waves. We're going to have two types of waves that we're going to discuss. So the first type of wave we're going to talk about is a longitudinal wave. Longitudinal. So a longitudinal wave is a sound wave. And what characterizes a sound wave is that the particles of the medium vibrate back and forth parallel. So let's say that the particles vibrate back and forth and the word I want to use is parallel. So that's going to be a defining notion for longitudinal waves, is that the movement is parallel. Okay, so we're going to draw what a compression wave, a longitudinal wave or compression wave looks like. So in our waves, do a nice job. Okay, a longitudinal wave is going to have, let's draw my wave looking like this. And then these are going to have a little bit more space between them. And then I'm going to do another part where these little wavelengths are closer together. Okay, so when they're close together like this, this is called a compression. So some people might also refer to this as a compression wave. So this is a longitudinal wave, and when the wavelengths are close together, it's called a compression. When the wavelengths are spread out, this is called a rarefaction. And these are vocabulary words that you're going to need to know. This is also a compression. To measure a single wavelength, you're going to go to a same point to a same point on that wavelength. So for this one, let's go from the end of this compression to the end of this compression, and this here is a wavelength. So in a longitudinal wave, a wavelength is measured from the end of one compression to the end of one compression, or beginning of a compression to a beginning, from two same points. So let's define our wavelength here. The distance between two of the same points. So in a longitudinal wave, that means compression to compression, or, and we're going to get to this in a second, from crest to crest. Okay, and that's going to bring us to our next wave. One more thing on the longitudinal wave. So here's our main points. Longitudinal wave is a sound wave. The particles vibrate back and forth in a parallel motion. This is what a longitudinal wave looks like. To measure a wavelength, you go from the same point to the same point. And a very important thing for longitudinal waves, must have a medium. So a longitudinal wave, a sound wave, let's add that. Sound waves only travel through a medium. And we can talk later about how you make a soundproof booth. Okay, I'm running out of a room. I think it's going to be, well, I didn't get it. If you need to change pages, go to another right page. Don't write on the back. Okay, so now we're going to talk about, so longitudinal is one wave. Our second type of wave is a transverse wave. So a transverse wave is known as a light wave. And particles travel perpendicular. I have to write it down here. Go back up here just to remind. So parallel, it's going to be like this. perpendicular looks like this. And how I remember this is perpendicular, transverse, perpendicular. It's the way I'm going to remember the difference. So this is what a transverse wave looks like. A transverse wave looks like that. So this top part here is a crest. And the bottom part here is a trough. So a crest, you can define that as the top of the wave. Trough is the bottom of a transverse wave. So a wavelength, the distance between two of the same points. So a wavelength here is a crest to a crest, or you could also do trough to trough. So this here is one wavelength. This is going to be the same. This is also a wavelength. So next class we're going to talk about counting a wavelength. Okay, but one other thing that we're going to talk a little bit about just for definition wise on a transverse wave that we're not going to talk about with a longitudinal wave is if you're having a resting point would go right through the center here. You don't need to know that. But the distance between this resting point and the crest, this is called amplitude. So if you're talking about, oh, the guy's got a lot of amps, this is amplitude. Okay. And that's all we're going to do for today is definitions. You can pause it at any point, go back and watch it. Thanks for taking your notes.